Good day. So, this is the video presentation of Group 2. I'm Farina El Maliga.
Good day everyone. So now we're going to explain how the Brahe's innovation and extensive collection of data in observational astronomy paved the way for Kepler's discovery of his laws of planetary motion. But first things first, when we say planetary motion, we're talking about how the planets move around the sun. So before the Kepler's discovery, the laws that explain this movement, people believed na po that planets move in the perfect circle. But Kepler proved that this was wrong. So instead, he discovered the planets move in oval-shaped orbits, which we call the ellipse. Itong lesson na ito is the strong evidence na yung Earth is not the center of the universe. Rather, it is the Sun is the center of the solar system. So, did you know that in the past, students took the ideas that they learned from their teacher as a legacy or an inheritance? So, one of the example is what I think that you most heard about is they're so-called the Big Three of Greek philosophy. So, Socrates, the founder of Western philosophy, Plato, the student of Socrates, and the founder of Academy of Athens. And while Aristotle, the student of Plato, and wrote the theory of universal. So, ideas that were created by students sparked from the first idea taught to them by their teacher. And that's how science worked during their time. So, hindi lang basta-basta natututo yung mga students dito, no? So, kailangan din nilang ipagpatuloy ang mga nasimula ng kanilang mga teachers. Tycho and the Changing Universe. The Danish astronomer Tycho made some of the most accurate ever observation with the naked eye in the late 16th century. So he disproved that Aristotle's concept of an unchanging universe when he saw a new star in the constellation of Cassiopeia in 1572, which he named Nova Stella. So this was later identified as a supernova. So Tycho also proved that Aristotle's transparent spheres do not exist by showing the comets would have to travel through them. So yun na nga no, finally yung mga ideas na ipinasa ni Aristotle noon is finally may kumontra, and that is Tycho Brahe. So sinabi ni Aristotle kasi na yun na yun. So kumbaga kung ano yung universe na nakikita natin is yun na yun. So it will not change. Pero one of the observation that made by Tycho was a supernova in the constellation of Cassiopeia. So yun na yung Nova Stella. So yun na yung mga ideas na ini-present ni Tycho Brahe, but it lacks more evidence and more experimental testing. So that's why si Kepler, yung student or the student of Brahe, continued the study and made the laws of planetary motion.
Good afternoon everyone, I am Maleha A. Mauyag and I'm from Group 2 Reporters in Physical Science. And today we're going to find out how Brahe's innovations and extensive collection of data in observational astronomy paved the way for Kepler's discovery of his laws of planetary motion. So, ang lesson na ito ang siyang mas naging strong evidence na ang Earth is not the center of the universe. Rather, it is the Sun, the center of solar system. But first, let's look at the history of Tycho Brahe and Johannes Kepler. Tycho Brahe and Johannes Kepler were two influential figures in the history of astronomy. Tycho Brahe was a Danish nobleman and astronomer who made extensive observations of the night sky using his unique instruments. He is best known for his accurate measurements of planetary positions, which he recorded with unprecedented precision. So Brahe's observations would later be used by Johannes Kepler to develop his laws of planetary motion. And Johannes Kepler was a German mathematician and astronomer who built upon the work of Nicolaus Copernicus and Tycho Brahe to develop his three laws of planetary motion. Kepler's laws describe the elliptical orbits of the planets around the Sun and the relationship between a planet's speed and its distance from the Sun. These laws were a major breakthrough in the understanding of celestial mechanics and laid the foundation for Isaac Newton's law of universal gravitation. So let's proceed at Kepler's laws of planetary motion. Johannes Kepler was a student of Brahe before he was hired to become a sort of research assistant by his teacher. So before hinire ni Brahe si Kepler as his research assistant, naging student niya ito. And Tycho later assigned Kepler the task of analyzing his observations of Mars. This move by Brahe is primarily to prove that Brahe's model, geoheliocentric model of the universe, is consistent with the available data. Kepler needed Brahe's data to do mathematical analysis, while Brahe needs Kepler to make mathematical calculations to prove that the model satisfies the observed data. So nagtulungan sila. And Brahe died before his model is proven. But Kepler didn't stop to find out what is the correct about planetary motion and what model must be correctly followed. So Kepler inherited vast data set that will prove crucial for developing his three laws of planetary motion later. So pinagpatuloy ni Kepler ang study ni Brahe hanggang sa magawa na niya yung three laws of planetary motion. It took Kepler many more years trying out many possible models to fit the available data, being concerned largely on the philosophical implications of his models and the belief that there has to be simple numerical relationships among phenomena like the Pythagoreans. Only after about 20 years or so working with the data he got from Brahe, the three laws of planetary motion were published in 2 different years. So, 20 years niyang pinag-aralan ang legacy ng kanyang teacher hanggang sa matuklasan na niya yung 3 laws of planetary motion. These 3 laws of planetary motion were published in 2 different years. Law of ellipse in 1609 and the law of equal area in 1609 as well, and law of period in 1619. And that's all.
The relationship between Tycho Brahe and Kepler. Tycho Brahe, a wealthy and meticulous astronomer, employed Johannes Kepler, who later used Brahe's extensive and precise astronomical data to formulate his three laws of planetary motion, revolutionizing our understanding of the solar system. Tycho Brahe was known for his meticulous and accurate observation of the stars and planets, and Kepler, a mathematician and astronomer, was initial an assistant of the Brahe.
Tycho Brahe was an astronomer from Denmark in the 16th century. He was known for making accurate observation of stars and planets using advanced instruments for his time. His data was important to Johannes Kepler, who helped develop the law of planetary motion. He also created a model called the Tychonic system, which combined the heliocentric and centric views. Brahe's model was a step toward a deeper understanding of the universe, and paved the way for important advancement in the science of astronomy.
Johannes Kepler was a German astronomer. Despite his health issues in childhood, he showed great mathematical talent. He studied at the University of Tübingen and became heliocentrist. Kepler's major contribution are his three laws of planetary motion. Using Tycho Brahe's data, he discovered that planets move in elliptical orbits. First law, a line joining a planet and the sun sweeps out equal areas in equal times. The second law, and the square of planet orbital period is proportional to the cube of the semi-major axis of its orbit. The third law. These laws were published in Astronomia Nova and harmonizes Mundi and revolutionized astronomy. He also made advancement in optics. In his later life, he faced financial problems and his mother's witchcraft trial. He created the Ridolfine tables and died in 1630. His work was fundamental for Newton's law of universal gravitation and the scientific revolution. Tycho Brahe, a Danish nobleman, started as a law student but became passionate about astronomy after observing a solar eclipse. He made groundbreaking observations at his observatory on Venus, challenging Aristotelian beliefs with his studies of a supernova and a comet. He developed a lunar theory and the Tychonic system, a mix of geocentric and heliocentric ideas. Forced to leave Denmark, he continued work in Prague, collaboration with Kepler. His life was colorful, marked by a duel that cost him his nose, and his death is mysterious. His precise observation were crucial for Kepler's law and the scientific revolution.
Good day to everyone. Today I will explain one of the three laws of planetary motion by Johann Kepler, the law of equal area or his second law. Alam ba natin kung paano gumagalaw ang mga planeta sa kanilang orbit? So, ang planeta orbit noong ika-17 siglo, isang German astronomer na si Johann Kepler ang nagbigay ng tatlong batas na nagpapaliwanag kung paano gumagalaw ang mga planeta sa paligid ng araw. Isa sa kanyang mga batas ay tinatawag na Law of Equal Area na may kinalaman sa bilis ng paggalaw ng mga planeta habang umiikot ito sa araw. Ang batas na ito ay nagsasaad ng linyang nag-uugnay sa araw at sa isang planeta na tinatawag na radius vector ay nagwawalis ng mga magkaparehong area sa parehong tagal ng panahon. So, ang ibig sabihin nito, kapag ang isang planeta ay mas malapit sa araw, ito ay mas mabilis gumagalaw at kapag ito ay mas malayo, ito ay bumabagal. Ngunit kahit nagbabago ang bilis ng planeta, ang area na na-sweep ng radius vector sa loob ng parehong tagal ng panahon ay laging pantay. Example of better understanding. Isipin natin ang isang ice cutter. Kapag inilapit niya ang kanyang mga braso sa kanyang katawan, siya ay umiikot ng mas mabilis, pero kapag inuunat niya ang kanyang mga braso, bumabagal siya. Ganito rin ang nangyayari sa mga planeta, mas mabilis kapag malapit sa araw at mas mabagal kapag malayo.
There have three laws. The first one is the law of ellipse. Law of ellipse, Tycho's data were accurate enough for Kepler to show in 1609 that Mars orbit fits the shape of an ellipse centered on a mass determined by the Sun in the second focal point. This is Kepler's first law. The law of ellipse somehow replaced the perfection of the circular orbits somehow accepted in all the previous models. In one sense, Kepler is saying that the new perfect shape must be an ellipse. In any case, a circular path is a degenerate ellipse with the foci merging as the center of the circle. So, another information about this law, the law of ellipse. This law is one of the key components of Johannes Kepler's first law of planetary motion, which was derived from the careful observation of the planets, most notably by astronomer Tycho Brahe.
Tycho Brahe believed that the Sun orbited the planet, but he also believed that the other planets orbited the Sun. Grabe na po. Tycho Brahe believed that the Sun orbited the Earth, but he also believed that the other planets orbited the Sun. His reasoning was that he should be able to measure the parallax of nearby stars if the Earth was moving around the Sun. Since he did not observe this, he reasoned that the Earth must be stationary. The fallacy in his reasonings was that the parallax angle of even the nearest star was too small for his instruments to measure. Since telescope had not been invented, his instruments were basically large protractors. He did, however, take very accurate observations of the position of the planets relative to the stars. Before the invention of the telescope, Brahe and his staff used a range of instruments to make the most accurate of observation that had ever been collected. This data was later used by Kepler to build his theories. As a result of this observation, Brahe put forward a new model for the cosmos. In Brahe's model, all of the planets orbited the Sun, and the Sun and the Moon orbited the Earth. Keeping with his observation of the new star and the comet, his model allowed the path of the planet Mars to cross through path of the Sun. Although Tycho Brahe published an Earth-centered model of the universe, his observation of the universe and collection of data was considered a huge contribution to our understanding of the universe.